the notes here. So basically what you're supposed to learn in this particular problem is that chi-squared homogeneity is what the chi-squared test is called. A chi-squared homogeneity means that you have two or more populations and you're trying to see if one variable that those populations share is the same. The ho is that there's no difference, and the ha is that there is a difference. The expected count is row total times column total divided by table total. Of course, the chi-squared goodness of fit, there's one sample, one population, one variable. The homogeneity, there's two samples, two populations, and one variable, or more. Or more populations, not more variables, only one variable, but you can have two or more populations, which one sample per population though. The calculator commands are right here that you can follow. I also have a video specifically on the calculator commands for homogeneity. For this particular problem here, it's asking you to do this the same thing. Go ahead and put this into your calculator the way I showed you. You're going to state that there is no difference in the distribution of response questions when asked by male or female, and aha, there is. I've got two populations, male and female, and I have one variable, and that's the same proportion to the response of a question. And then I'm going to calculate the chi-squared statistic and calculate the expected value. So I'm showing my work of how to get male yes and female no, and male no and female no. However, you can put this in your calculator because this is just the expected value. So you can put it in the calculator the way I showed you before, where you make a matrix and then just hit variable after your observed matrix is entered into your chi-squared two-way test. If you would like to see that demonstrated, go to my videos, which show specifically the chi-squared two-way test. All right, and then calculate the chi-squared value of the statistic, and you can show, here's my work showing it by hand, but of course, if you have the formula and you have all of your numbers in the chart, that's all you need. Okay, next part that I'm just going to show is our taco tongue and evil eyebrow independent. Okay, so taco tongue and evil eyebrow, we're trying to see that's going to be two variables. Taco tongue is a variable and evil eyebrows a variable, but I'm using a sample of 600 senior students from one population. So independent, we're doing a chi-squared independent, and this has one population and two variables. And we're trying to see, are the variables independent? So let's go ahead and see what the setup is, and then I'm going to go ahead and put everything together for you. So describe what it means for two events to be independent. And that's what it means is you don't know if one event does not change the outcome of the other event. Same way to get expected count, row total times column total over total total or grand total. So if I'm trying to find the expected counts of this one, I would take 180, if I was trying to do for taco tongue. So that would be 480 times 200 divided by 600. And if you do 480 times 200 divided by 600, you're indeed going to get 160. You would do that for all of them, or let's put it in the calculator. So just in case you didn't see my other video, I'm going to show you how to put that in the calculator. So open up a calculator page and then name your test. So if you name your test, I'm going to name the test, begin, I guess, today. All right, so then you're going to push the button to control and then the button to the right of the 9. Now my iPad's a little different, so when that becomes control and button to the right of 9, you'll see colon and then you'll see an equal sign. So control button to the right of the 9 is what that does. Then you're going to hit the button to the right of the 9 again, and it's going to bring up a menu where you're going to be able to choose a matrix. And I'm going to do it 2 by 2. You never put in your totals, just the raw data. So I've got 180, 20, 300, and 100. Okay, so now it has been entered into the calculator, and now you're going to run the test, which is menu, stats, test. So yours will be, let me do it from the beginning, menu, stats, test, and then it's going to be a chi-squared two-way test. So the observed matrix on yours is begin, because that's what I called it. I hit OK, and then this is my test, but right now what I'm looking for is my expected matrix. So again, variable is the button above the 9. On mine it's a little different, and I'm going to go down to expected matrix. So you'll see expected, stat expected. And those are my expected values, which is just the row total times the column total divided by the total. And that is what we got here. Your hypothesis, of course, is going to be taco tongue and evil eyebrow are not associated, and taco tongue and evil eyebrow are associated with a significance level of 0.05. If you check your conditions, you have a random sample of 600 seniors. You have the 10% rule, and then the large counts, you're going to see all the large counts are greater than 5, and the observed counts are counts, that you make sure that they are counts. And they're independent from each other. That's a random independent sample that each senior is independent from himself or herself. All right, so let's go ahead, and this is my work. So if I'm doing my phantoms, I would just do, of course, my next, again, you do not have to have this here if you do the chart like I told you. So you're going to have your observed, your expected, and then you would do your chi-squared, which I didn't do the chi-squared yet. You'll just hit variable, which is the button to the top of the 9, and then you're going to go to the stat. It says stat comp, which is component matrix, and those are my components. If you add 2.5, 1.25, 10, and 5, you actually get that 18.75, which is your chi-squared component. So you can show your work this way that it has here, or you can show your work the way I do it, which all I do is in the chart, I just call it observed, expected, and chi-squared, and I do 180, 160, and then my other one, which was my component, which is 2.5. Anyway, I do that for all of them. And I would go ahead and put it, I would put it for all of them so that it would actually count for my work. And then for my work, and then I just have to make sure that I use the formula, and then of course that I still put 18.75. I label my chart. In my chart, this is a chi-squared degrees of freedom of 1 because it's still row minus 1 times column minus 1. And then you need this to be 1875, and this is your p-value. Okay, I have a p-value that is really tiny, so p is low, and so I'm going to reject the null hypothesis and say that there is convincing evidence. And which one, I kind of look at it and I see, all right, which one is the one that caused us to have which had the highest chi-squared value, which caused me to reject? And that was the bottom left, which is those that have, the bottom left one, if I look here at my data, it's those that have evil eyebrow and no taco tongue. So this one here was the one that had the highest chi-squared value. All right, looking at the notes, you're going to have chi-squared test for independence, where ho is there is not an association and ha is that there is. And how do you choose which chi-squared value? If we're going to review and we look at the chi-squared value, remember the chi-squared goodness of fit we did with M&Ms, and also we did with birthdays. That was the one we did. And that had one sample, one population, one variable. Gummy bears, we had two or more samples, but we used just 2 samples in ours, Haribo and Meyer. And you had one variable, and that variable was color. With the chi-squared test of independence, it has one sample from one population and 2 variables. All right, for the answers for this, you can see this is a chi-squared test for independence because it's from one sample, it has 2 variables. Number 2 has 4 samples and 1 variable, and I'm trying to see if they're the same. And the last one is 1 sample from 1 population and 1 variable. If you need any other help, go ahead and check out the other videos on those things. Thank you.